Hello everybody, welcome to the video for section 3.3, aka properties of division. In this video I will go over a quick introduction with some vocabulary regarding division. Then we'll look at a polynomial divided by a monomial, then polynomial long division, synthetic division along with the remainder and factor theorems, and the zeros of a polynomial given a zero. Let's get into it. The vocabulary for this particular section really breaks down into a few words for division. We have the dividend, that is the part being divided on top, first, or inside. We have the divisor, the part doing the dividing on the bottom, last, or outside. You can see it outside and inside here. The quotient, that is the answer on top of any division, because we'll be doing a lot of dividing like this. And then the remainder is anything left over at the end. All right, let's take a look at division by a monomial. Oops, there we go. And what that looks like. Now, you may have seen this done with the quadratic formula before. It basically is separating and simplify. And what that looks like is it'll be 30b to the 9th all over 6b to the 3rd minus, because there's a minus here, 3b to the 7th over 6b to the 3rd, a plus, because there's a plus here, 8b to the 4th over 6b to the 3rd. All right. So separate into as many fractions as there are terms in the top of the fraction. You can see here 3 terms, 3 fractions. Then you move to simplify each fraction. So simplifying each fraction would look something like this. This is what you would get if you simplify each fraction over here on the left. Now, a couple things to point out. 3 over 6 does reduce to 1/2, and b to the 7th over b cubed does reduce to b to the 4th. And you can either leave that behind the fraction, as you have been trained to do with putting letters behind numbers, or you can leave this b to the 4th in the top of the fraction as if it were b to the 4th over 2. And you can do something similar over here with this fraction. Okay, we've got a polynomial divided by a monomial. Check. All right, next little bit here will be polynomial long division. I'll just scroll up a little bit here. Okay, so polynomial long division. Set up the polynomial division like the figure above. That's printed on the notes up there. The divisor outside and the dividend inside. The goal is to find the quotient and the remainder of the division, and there is a process for this outlined below. So set it up as I mentioned over there. So we will take the dividend and put it outside, and we'll take the divisor and put it inside. And that's quite literally what the first step is. The next step is to divide the first term inside by the first term outside. So I'm just going to do that off to the side. I'm going to say 4x squared over 4x equals, well, that's just x. Then you will line this answer up to the top. And the way you line things up in polynomial division is by the exponent of the x. Since this is the term that had x to the first power, x to the first power will go above it. It's just an organizational tool. The next step here, step 3, is to multiply the new term in the quotient by the divisor, and then you'll line those up under the dividend. So you're going to take this x and multiply it to 4x and 1. And when you do that, you'll get 4x squared plus x. And again, you line those up by the powers of x. You can see all the x squareds are above and below one another. All the x to the first powers are above and below one another. From there, step 4 says change the sign, draw the line. So changing the signs means just change the signs of whatever you just put there. Draw the line so you can step 5 combine. What will happen every time is that those first two, the first term should cancel out, and potentially more based on the exercise you're working through. But then you can combine minus 7x minus x to get a minus 8x, and then you can bring down everything else. In this case, it's just one term. And what do? You repeat the process. So the first term inside now is minus 8x, and we'll divide that by 4x. I'll do that off to the side. So here's the division, and the result is minus 2. We'll put it up here, but now this time we've already multiplied the x over here. So now we'll multiply only the new term by the dividend, and we'll just line things up underneath again. So negative 2 times 4x is minus 8x, and negative 2 times 1 is negative 2. So then you'll draw the line, or change the signs. That's a negative, it'll become positive. This is a negative, it'll become positive. Draw the line and combine. Turns out when you add negative 8 and 8 and negative 2 and 2, you'll end up with a 0. Now, I know to stop here because the degree of the remainder, this is degree 0, no x's, is less than the degree of what's outside. So we had to do one more round of dividing here because the degree of what was left is equal to, it has to be less than, then we can stop. So what is the answer? Well, we could write it out a couple different ways. We could have the quotient, and that is just whatever is on top of the division sign there. It's x minus 2. And the remainder is 0. Or we could write it out as an answer, and that would be the quotient plus the remainder over the dividend, in this case, which was 4x plus 1. Now it's silly to write this last remainder. Whenever the remainder is 0, 0 over anything is just 0, so we don't really need to write it, but here we are. On to the next slide. On this slide, I will be finishing up the polynomial long division examples and then start with synthetic division in the next video. All right, let me zoom in and get through this particular long division. So here you can see we have divide the following polynomials: 5x squared minus 14x to the third plus 3 minus 4x divided by 2x plus 5. Now, one thing you'll want to keep in mind as you do these is just make sure the polynomials are in order. So the 2x plus 5 will go outside. And if we write the polynomial, quote, in order by exponents, we'll have a minus 14x to the third plus 5x squared, minus 4x plus 3. And we just follow the process from the last example. That is the first term inside divided by the first term outside. So minus 14x to the third power over 2x, well, that'll be negative 7x squared. Line everything up. Multiply to the dividend. That will require distribution to the 2x and the 5. So that'll be minus 14x to the third power and minus 35x squared. Okay, we will change the signs. That was negative, it'll be positive. That was negative, it'll be positive. Draw the line. And then step 5 is combine things together. The first term cancels. We can combine everything else over here to be 40x squared. Bring down everything else. Minus 4x plus 3. And we start the whole process over again. First term inside by first term outside. So that's 40x squared all over 2x. That equals 20x, which will go in the top along with all of the other x to the first powers above and below it. From there, we will multiply 20x to both the 2x and the 5. We'll get the following. That will be 40x squared. Oh goodness, plus 100 x's. We will change the signs from positive to negative, draw the line. Step 5 is combine everything together. Again, the first term cancels. This is a minus 104x, bring down everything else, plus 3. First term inside by first term outside. You all tired of hearing that yet? This is negative 52. Minus 52. We do all of the sign changing and combining. Minus 260 becomes a plus 263. Okay. And again, we had to keep going. After we combined here and brought everything else down, the degree was still bigger than. After we did it here, the degree was equal to. We need the degree to be less than what's outside. Then we can stop. All right, so how can we give our answer? We can give our answer one of two different ways. We can say the quotient and remainder separately. The quotient is whatever was at the top of the division there. It's minus 7x squared plus 20x minus 52. And the remainder is whatever is left down here, 263. Even if this number, this remainder was 0, you would still say it's 0 here. You just wouldn't add it as part of the answer that I'll be writing out right now. So the answer, if we combine everything together, if the direction is just divide, then the answer here will be the quotient. So it's minus 7x squared plus 20x minus 52 plus the remainder, 263 all over the divisor. Either of these answers is okay. If it asks specifically to list out the remainder and the quotient, then you will list this answer. If it doesn't say to list out the quotient and remainder explicitly, then you will list this out as the answer down here. Okay, one more example over here with a little bit of a extra piece of information that I need to get out there before I pause the video and give y'all an opportunity to try this. With this one, you can see that we have a x squared plus 5. That'll go outside. And then what goes on the inside is 3x to the 4th plus 13x cubed. And way over here, I'm going to write minus 15 for no reason whatsoever. If you start with the first term inside divided by first term outside, you get 3x to the 4th all over x squared. And that gives you 3x squared. And this is the first thing I need to point out before I tell y'all to pause the video and try it on your own. This should be going above and below other x squared terms, except I don't see any here. So if you have any missing powers of x, you need to put zeros in there. This will not be the last time you hear this. So now that I have put 0 terms in for the missing powers of x, I have a place to put this here. They're all above and below one another. From here, you multiply, so this is going to be 3x squared times x squared and 3x squared times 5x. And when you do all that, you'll see that you end up with 3x to the fourth, and 3x squared times 5 is plus 15x squared. And again, it all just lines up above and below one another very nicely now that we've put that 0x squared term in there. Another thing you might notice about this is that since you did this distribution, you skipped right over the x to the third term because, x squared times x squared is x to the fourth, x squared times it is x squared. So we skipped over that. Don't worry, you can still draw the line and change the sign so that will become minus and that will become minus. And you can combine things together, but you're also bringing down this 13x to the third power. Just don't forget about that, and you should be fine. This will be plus 0x minus 15. Okay, pause the video, try this one the rest of the way. Give your answer as both a quotient and a remainder, and as just an answer. Okay, here's the entire solution laid out right for you. So what happened? We left off right here in this line. Take the first term inside divided by the first term outside, get 13x, it goes to the top. Make the distribution of the 13x to both of these, and you'll get 13x plus 13x cubed plus 65x. Change the signs, draw the line, combine. The first term will always cancel. Bring down what's needed, combine whatever is left, and we're here. First term inside by first term outside gets you minus 15x, just minus 15. Distribute. Line things up. Change the signs. This was minus, this used to be minus. Change the signs, made it positive. Draw the line. Combine, bring things down, combine whatever's left. And we can stop here because the degree is less than the degree of the divisor. So you can see what the quotient is. I'm not going to write these down next to one another like I did in the example over here. Right here, quotient and remainder. But you can see what it is. You'll just write it down next to one another. Right, there's the quotient at the top, there's the remainder on the bottom. The question is, how would you write this as just the answer, we'll say. If it's not asking specifically for you to separate the quotient and remainder, this is how you will write it. So 3x squared plus 13x minus 15. You write the quotient, and you write add, and I'm just going to put a fraction behind it. The top will be whatever the remainder was, 65x plus 60. No need to worry about factoring anything here. And then the denominator is the divisor, x squared plus 5. And then this is what the answer would look like. See y'all in the next video.